Okay, here we go. So welcome to 7.3, third lesson of the probability distributions. Again, these are discrete distributions. The next chapter talks about continuous distributions, and that's something called a normal distribution, but this is our third discrete distribution. So let's write. Okay. Let's do a little review. Like a binomial distribution, a geometric distribution has a specified number of independent trials, i.e., so the probability of success and failures don't change. If they're independent, they remain constant. And it also has two possible outcomes, success or failure. So that's how it's similar to a binomial distribution. Unlike a binomial distribution, the difference is the variable is different. The variable is the number of unsuccessful outcomes before a success occurs. Basically, how long do you have to wait for a success? That's basically what the variable is. So, again, this is the geometric distribution. How it compares to the binomial distribution. The binomial was the variable is the number of successes. So it's pretty much the exact same thing. It's just that we're measuring something a little bit differently. Here, binomials, how many successes did you get? Geometric, it's the same thing, but how long did you have to wait before you got a success? Does that make sense? It's kind of almost exactly the same. So an example. How many of you guys have played the game Monopoly?
I have.
All right.
I have.
Okay, it's a good game. So if you're in jail, how do you get out of jail?
You have to roll the dice.
Yes, and what do you have to get?
Doubles.
You have to get doubles. So to get out of jail, in the game Monopoly, you must roll doubles. What's the probability of getting doubles?
Wait.
6 out of 36.
Yeah, there's 6 ways, remember? You get 2 ones, 2
I
twos,
knew
2...
that off the top of my head.
We've done this a few times now, right?
Not much.
You guys have done this a few times, right? If you have 2 dice, 1, 2, you can get... This is die 1, this is die 2. How many ways you can get doubled? You can get 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, or 2 6s, right? And so there's 6 out of a total of 36, right? 6 by 6 is 36. So there's 6 over 36 ways to get doubles, and we reduce that to 1 over 6. All right. So here we're going to say calculate the probability distribution of getting out of jail in X rolls. So you can only get out of jail once you get a double, right? So the random variable, this is a geometric distribution. It's the number of unsuccessful outcomes. So it's the number of unsuccessful rolls. All right. What's the lowest number of unsuccessful rolls you can have?
0.
0, because you can have a successful roll right off the bat, right? And then in the first few rows, you could have 1 unsuccessful roll, you could have 2 unsuccessful rolls, you can have 3 unsuccessful rolls, you can have 4 unsuccessful rolls, and then we'll just generalize it to X unsuccessful rolls. All right. So, what's the probability of getting out in one roll, rolling a double in one roll? Remember, the probability of success is what? So rolling a double, P equals 1/6, right? If P is 1/6, what's Q? So probably P is again
5 6.
5 6, right? So if you leave a little bit of space here, so it's going to be the probability of getting out in one roll is just going to be 1 over 6, right?
Wait, but how? You haven't rolled.
But it's the number of unsuccessful rolls. So that means you keep on rolling. Let's skip 0 for a second. So it makes, like, if you look at the second one, you have 1 unsuccessful roll, and then you followed it by a successful roll. That makes sense? You actually have 2 rolls. You have 1 unsuccessful and then one successful. This would be, what would be the probability of the unsuccessful?
You want to be a half?
No. So remember, each roll that's unsuccessful has a probability of 5/6. Each roll that's successful has a probability of 1/6. So if you have two rolls, one being unsuccessful and one being successful, remember, we're only tracking the unsuccessful ones here, but remember, there's always one successful at the end, right? Because we're doing the variable is the number of unsuccessful outcomes before a success occurs, right? So at the end, we're always going to have a success. So here, we're having...
So it's 5/6?
It'll be 5/6, and that's the unsuccessful roll. We still... Remember, this is actually two rolls. One unsuccessful, and then one... And then it's going to be... That's the unsuccessful roll. 1/6. And then what would be if you had two unsuccessful rolls?
Oh, 5/6 times 5/6.
Yeah.
Never mind.
So 5/6 times 5/6, which is 5/6 squared,
Times 1/6.
times 1/6. What about three unsuccessful rolls?
By 1/6.
What's that?
Why do you have to include the 1/6 if you're
Because
talking about unsuccessful rolls?
yeah, but we're following it by one. Like remember, it doesn't talk about the success, but it's we're always tacking on a successful roll at the end of the unsuccessful
Okay.
rolls. Okay, so even though it says one here, there's one unsuccessful roll, and then there's one successful roll. Here, there's two unsuccessful rolls and one successful roll. Right, so and each unsuccessful roll has a probability of 5/6. Now we have three of them. So it's 5/6 times 5/6 times 5/6. We haven't got our success yet. And then at the end, we get a successful roll. Right? And here it's 5/6 to the fourth, and then times 1/6. Let's go back to the top one. This is actually like, let's put a bracket here and put 1, just to make it, consistent. Just to make it consistent, what could be right here?
5/6 to the 0.
Yeah, which you probably wouldn't do, but because that's just 5/6 to the 0. Anything to the 0 is 1. But if you want to be consistent, so in general, this would be 5/6 to the
X.
times 1/6. I'm going to give you the numbers here. This is going to be 0.16. I'll just round it to 7. This is going to be, you're going to take my word for it, 0.13.
Sir, I will verify your answers for you if I can find my calculator.
Hershey's questioning your capabilities.
Sir, I cannot find my calculator, so I will have to trust you.
You're going to have to trust me on it. I can't even read my own handwriting. What the heck does this say? 0. All right.
Sir, what does that one say? 0.096?
Yeah. And I'm just going to add 2 more. 5. 0. What does that say? 6, 7. And 6. 0.056, I think. So so remember, you can show, this is a distribution table. Did we show all possible entries? Is it done? Is it possible to go higher than, I did 4 here and then 5 and 6 there. Is it possible to go higher than 6?
You have successful rolls?
Yeah. Can you have more than 6 unsuccessful rolls?
Yeah.
Yeah, you can have 7. You can have 8. You can have, does it have an upper limit?
No.
It's very unlikely to have 1,000,000 unsuccessful rolls, but theoretically it could be. There is a small probability that could happen. So it's infinite. It's an infinite series. But what happens if you add all these infinite probabilities up? What do you add up? What do they add up to?
1.
1. So you have an infinite series that adds to 1. And if you don't take calculus, that might not make any sense. But if you take calculus, you should know by now that you can add infinite series to get a finite answer. Right? You guys know that?
Not really.
Okay, so
No, sir.
let's just do...
No, we don't have that graph.
We don't?
Sir, I don't have it either.
We don't have
Yeah,
it
it's not on the sheet. So when you put the sheets, everything It's different than from what your sheets are.
It's like shifted down.
Yeah.
Yeah, everything's a little off.
Huh.
Tanner?
Are the words the same?
Yeah, the words are the same.
The majority of the
Kind of like
things
shifted down.
You don't
I don't know why
have,
the graph is.
you guys don't have a grid there?
No.
No.
Is there
I don't want to draw it.
is there room to make a grid?
Yeah.
No.
Okay. If you can, I'll show you what I'm expecting here. So, number of unsuccessful trials,
I'll draw a grid, sir.
and we're going to have 0 unsuccessful, 1 unsuccessful, 2, 3, 4, 5, 6, and then we're just going to probabilities. I think if I put this as this is going to be awkward for you. You don't have to do this, I guess. What's 0.5, 0. Oh, sorry, 0.05, 0.1. This will be 0.15, something like that. And if you just punch in this, so the graph would look something like this. 0.167 would be like right, there somewhere. And then that's this one. And then the probability of having one unsuccessful trial, i.e. you have two rolls, first one being unsuccessful. So the probability of that was 0.139. Where would that be? That would be like right there, maybe, I don't know. And then 0.116, that's almost 0.12. That would be like there somewhere. And then 3 is 0.096, a little bit less than 10. 4 would be 0.80, maybe there. 5 would be 0.67, maybe there. 6 would be 0.56, maybe. It's an exponential curve, it goes down exponentially. Each subsequent number is 1/6 less than the previous number. Does that make sense? It's exponential. And does it ever hit 0? No. There's an asymptote there. It'll always get very, 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 very close to 0, but it will never approach 0. So there is a probability that you can roll doubles. You can roll 2 dice a million times and never get a doubles, but it's very, very, very unlikely. Okay. So how are you guys on putting this graph in your version? You need more time?
Yeah, so 2 minutes.
Okay.
Yep.
If you're watching this video, you can just advance it a minute or two, okay? If you're watching this at a later time. Just let me know when I can go. I apologize for that. I should check to see which versions. I probably gave you an older version.
Yeah, I'm good, sir.
All right, so again, both of these are probability distributions. This is as a chart. This is as a graph. All right. Just like binomial distributions, so this is very easy. So the probabilities. What's the general formula for this? So it's in this particular case it was 5/6 to the x times 1/6. So what's the 5/6 again? So
Unsuccessful rolls.
5/6 was that failures or successes?
Failures.
Failures. So what's the letter for failures?
Oh.
Yeah.
I don't know.
I know failure starts with an F, but no. In math we use the letters P and Q. Which one's the success? Yeah, it's Q. That's the failures, and then it's to the X, and then it's times the 1/6, which was the P in this case. So let's just put that in the box. So very simple formula, very simple. So where P equals probability of success, and Q equals prob of failure. All right.
Wait, so P is probability of success?
Yeah.
Oh, okay.
I'm just trying to show what,
Oh.
explain the formula. All right, so let's just look at this example. So the probability of rolling doubles is 1/6. What is the expectation? I.e., how many rolls do you think you would have to roll on average to get a success? Just give me a number. What do you think? If the probability is 1/6, how many rolls do you think you would have to try before you get a double on average? Like, how'd you know it was 5? The answer is 5. I was expecting, why didn't you say 6? I was expecting people to say 6.
Oh my God, I got it right. I'm so happy.
Okay, so the answer is there's a formula. The formula is just Q over P. So again, for geometric distributions, both formulas are really easy. So let's just look at our example. So our example above with the Monopoly rolls, e to the x, the expectation would be probability of failure. So failure is the bigger one, right? Failure was the 5/6 divided by the probability of success. 1/6 equals 5. So 6's cancel out. So basically it would be 5 rolls on average.
Oh, isn't expectation n times P? Or is it different? Never mind.
This is a different, so this is a different variable, so it's a different formula. Oh, this doesn't make sense. So 5 rolls on average before. Okay, and I know why it's 5. 5 rolls on average before a success. So if you include the success, right? The success would follow the 5, right? So on average, it would take you 6. You would get the success on the 6th roll. Okay, that makes sense. So, i.e., success.
So what's the form for the expectation? It's EX equals what?
Q over P.
Oh.
I put a slanted line. Yeah.
Oh, no, I just couldn't read the Q properly.
Okay.
I wonder what.
All right. So this distribution theoretically continues forever. I.e., you never get a double roll. So this is an infinite series, and even though it's infinite, or we already talked about it, its terms sum to 1. All right, so this one's not too difficult. I don't think it's probably the easiest one of the bunch. Let's do some examples. Are we ready to go?
Yes.
Yes. Okay.
Never mind. We have to wait for Saha.
Okay, I'm good to
Okay. Okay. If you're commenting, while I'm teaching, I don't see those comments, So you can do that if you want.
I don't think anyone commented yet.
Oh, okay. Well, you can try it. You can say, "Hey, this guy's crazy. I don't know what he's talking about." I won't see it.
Krishna said that a few times.
Oh, what is this? Do you have? Wait, this is not the right handout. This is not the right handout. Now I see. Well, ho. Do you have this version?
That's
That's what we have.
That's what you have?
Yes.
Or do you have this version? Do you have the one in columns, or do you have the first one?
Oh no, we have her. No, yeah, like that.
We have that version.
I don't like this version.
Oh,
Wait,
Oh well.
are the questions exactly the same?
Yes.
Yeah.
Well, yeah, you don't see this version. But I put my answer key. Why do I have? This is weird. Okay, well, we'll use your version. Looks like I like the formatting better on the revised version, but hey, there's more space. Okay, the probability of Stacy passing one of her data management tests is 71%. Obviously, that changes over time, but we are going to assume that that's a pretty constant percentage. I don't know how that would work, but anyway, let's just go with the flow. What is the probability that she will not pass the first 4 tests? So it's basically 4 unsuccessful trials. It's basically, what does that look like? It looks like F, 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 F. Right? All right. So let's just look at what P is and what F is. Oh, sorry, Q. So P is
71%.
71% or 0.71. So pass. And this is a success. And this is a fail. And is unsuccessful. Alright. And so Q equals what?
0.29.
Okay. So, and again, you got that by they have to add to 1. So the probability of 4 failures, you don't need a form. It's not asking for the number of unsuccessful trials before a successful one. It's just asking for the 4 unsuccessful trials. So there's no like S behind it. It's just 4 Fs. Does that make sense? Like it's not asking. It's not talking about the successful roll, the pass at the end. It's just talking about the 4 failures right off the bat. So probability of 4 failures is what? So each failure has a probability of what?
0.29.
And you're doing it how many times? How many times are you failing?
4.
4 times. So it's going to be 0.29 times 0.29 times 0.29 times 0.29, which is 0.29 to the 4th. And that's pretty low. That's a pretty low percentage. You know, she has a 71%.
That's good.
So that's good. You don't
Don't you time?
you don't want poor Stacy to fail all 4 tests, do you? Anyway, so that's
No.
really small.
Wait, don't you do 0.24 to the power of 4? No, sorry, 0.29 to the power of 4 times 0.71. Or no?
Well, that would be if the question was worded, what is the probability that she will have her pass on the 5th attempt? That would be like 4 failures and then 1 success. There's no. It's not asking about if there was a success in there at all. It was just failing 4 times. No success. You'll see the difference when we go on. Okay, there's only 4 failures. There's no successes here. So that equals very low percent, 0.7%. All right. What is the probability of Stacy passing on her 3rd try? So here she actually is going to pass. This is going to be like fail, success. Right? So remember, what is the variable for a geometric series? It's the number of So if you look at our notes, it's the number of unsuccessful outcomes. So how many unsuccessful outcomes does she have here? So X is number of unsuccessful outcomes.
2.
Yeah, X is 2. So just remember, if she gets successful on her 3rd try, that means X is 2. The number of non-successful trials is 2. Okay, so now we're doing probably that X equals 2. You can just write P2 if you want, P bracket 2, but I just is going to equal. So what's the formula? It's going to be 0.29. The failures times 2. Not times 2, squared. 0.29 times 0.29. Right? We're just using this formula here. Right? So x is 2. What did I write here? Number of equals 2. Okay. All right. So and then times. We still have to do the p part. We do have a success, right? So okay, what is that? That's going to be. Well, if you punch it in your calculator, you just want to take my word for it.
I can't find my calculator, sir.
All right, that's fine.
I guess we have no other choice.
So 5.8%. If her probability of passing a test is 71%, the probability of her failing on the first 2 tries and then getting a success on the third try is only 5.8%. So most of the time this will not happen. What is the expected waiting time before she passes a test? What's the formula? Very simple formula.
Was it N over
Oh, P over Q.
No.
Yeah.
Q over P.
Q over P. Right, so that equals Q is 0.29. P is 0.71. That's going to be less than 1. So more than likely she will pass. That makes sense because there's a 71% chance she passes the first test. So it should be less than 1. And the answer is 0.41 tests. Right, so it's less than 1. All right, let's do the Jamal one. Jamal has a success rate of 68% for scoring on free throws in basketball. What is the probability that he will score on all of his first 8 tries? So this is going to be S, 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 S. So that's pretty easy. Again, we're not asking, there's no, you don't have to use the geometric formulas for this. It just, you have 8 successes in a row. So what would that be? It's the probability of this happening times the probability of that happening times the probability of that happening.
0.68
Yeah. To the
to 8
to the 8, right?
power of 8.
Okay. And that's I'm just gonna put the answer 4.6%. Okay, you're just gonna trust me on that one. All right. All right. So, and that's that's a good average, just like an NBA. Like most NBA players are a little bit better than that, but yeah. So what is B? What is the probability of Jamal missing 3 shots in a row only to score on his 4th try? So that's going to look something like F, 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 failure, 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 success. So in this particular case, so again, the success is scoring. So again, P is 0.68, and again we have Q equal. What's Q this time? We didn't calculate Q up here, but Q is, what's Q? The probability of failure?
0.32.
0.32.
Is that right?
Yeah, they have to add to 1. So this equals 1 minus
Quick mental
0.68.
math.
Okay. Alright, so they add
Good
to 1.
job, Krishna.
So,
Even this year.
so the probability in a geometric series of x equaling, oh sorry, I shouldn't have been told you. So x is, the variable is the number of unsuccessful trials. So I gave you the answer, x equals 3. So it's not 4, it's 4 tries, but 3 unsuccessful ones. So just remember that the variable for a geometric is the number of unsuccessful tries before a success. So here this would be x equals 3. Alright, so it's going to be, the probability is going to be, what? Give me the formula then? The numbers?
0.68 to the power of 3 times 0.32.
Nope.
Oh, it's opposite. Sorry, it's the wrong way.
Yeah, the other way
It's
around.
0.32.
to the power of
0.3. To the power 3.
yeah.
Times 0.68.
All right, that's going to be. I'll do the calculation for you. It's 2.3%. So it's pretty low. If he's a 68% free thrower, the chances of him missing the first 3 is only 2.3%. It's pretty low. What is the expected waiting time before he misses the basket on a free throw? Okay, so what is the expected waiting time before he misses the basket on a free throw? So what is P and what is
Q
Q?
over P.
Hmm?
So 0.32 over 0.68.
So it's a little tricky here. Look at the question. The question is,
Do you have
So
to
you-
flip it, sir?
what's that?
You have to flip it like 0.68 over 0.32?
Yes, why?
Because it's asking how many times before he misses, so we're assuming that we're waiting on an unsuccessful trial
Yeah, so
rather than
here,
waiting on a successful.
here our definitions are reversed. Here, success is what we get up at the end, right? So the success is what the final thing will be the success, right? So the failures will be the ones that he gets it in. So here, success is not scoring or missing the throw. Does everyone get that? See, so whatever this word is, that's at the end. That's here. Success is missing. Ah, shoot. Okay. So the success always has to be the one at the end. So the success is missing. So what's the P and what's the Q? If the success is missing, the P is the missing now, not the getting it in. Right? So the P now here is what? Here P was 0.68 and Q is 0.32. So now, but this is for the probability of getting it in. But now, here success is missing the basket. So here the probability of the success is flipped. Right? Missing a basket is 0.32 and getting it in is 0.68. But this is our what we're trying to get, the success, which is the missing the basket. I don't know. Did I lose people there?
A little bit.
A little bit, but you know what? Like, I'll let it marinate for a bit, and it'll eventually make sense.
Okay. So,
Yeah, I think
what is the
that'll
expected waiting time before he misses a basket? Remember? So, when we have
Q over P.
when we have this formula, it's always the failures first, and then the success. The success is what you end up with, right? So you're ending up with missing the basket. So that's the success. The failures are getting it in. Even though in basketball normally getting it in is a success, but here mathematically getting it in is the failure, because the one that he ends, the last one is the one where he misses, and that's by definition the last one is the success. Anyway, I'm going to not belabor the point. Hopefully you understood that. But okay, so e to the x is going to be q over p. So it's going to be q 0.68 over 0.32. So that's going to be bigger than 1, bigger than 2 actually. It's going to be 2.1 free throws. So on average, it's going to take him, he's going to throw a little bit more than 2 free throws before he misses one, on average, if he did it like 1,000,000 times. Alright, last question before we finish off. What is the probability that he will score on one of his first 5 shots? We're going to do it 2 different ways. We're going to do it, let's do it the direct way, and we do it the indirect way. Let's do direct way first, even though it's more complicated. So now, what's the P? So what is the probability that he will score on one of his first 5 shots? Oh, one of his first 5 shots. So scoring is a success. So P equals scoring. Q equals missing. Right, and this is scoring was 0.68. All right. So that he will score on one. What is it asking? What is the probability that he will score on one of his first 5 shots? So either either he throws a free throw and gets it right away, or he does 2 free throws, misses the first one and gets it on the second one, or he does 3 free throws, misses the first 2 and gets it on the third one, and so on. That's really what it's asking. So he's going to stop after he gets his first basket. Okay. So the direct way, if the variable is unsuccessful attempts, i.e., he misses the basket, how many unsuccessful attempts can you get if you take 5 shots? And he has to get, he has to make at least one. I don't know if I worded that question properly.
So I don't get it.
Okay. He's taking up to 5 shots. He can either get a success right away, he can make a basket right away and stop, or he can get the basket on his 5th shot. If he gets the basket on his 5th shot, how many misses will he have if he gets it on his 5th shot? 4. So again, he's going to stop after he gets his first basket. Okay, that's it's not really worded that well, but that's what the question means. He's going to stop after he gets his first basket. So the number of unsuccessful ones is going to be, X is going to be between 0 and 4. He's going to, if X is 0, it means he's got the basket right away. If X is 4, he's got 4 unsuccessful trials, and he'll
for sure make it on his 5th.
And he makes it on his 5th. Right? What it didn't say in the question is it should have said he stops shooting when he makes a basket. That's what was missing. So anyway, so this is going to be the probability of X equals 0 plus the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3 plus the probability of X equals 4, and you're not going to have a lot of room here. So the indirect one is really short. We can probably fit it in that space there. So we probably have all the space to do the direct one. I apologize. It was formatted a lot better in future versions. Okay. So let's just do the first one. So probability of getting no unsuccessful trials. Let's do the first one. So just that part. So he gets a success right away. What would that be? He gets a success right away. So it's Q to the 0 times P to the 1. So, right? So that would be Q to the 0, 0.6. Oh, might as well put it in. 0.32 to the 0, which you don't really have to, right? Times 0.68 to the 1, right? So that doesn't happen. It was just that. Yet it's 68% chance he scores on his first try, right? Let's do the second one. There's going to be 1 miss and then 1 success. So that's going to be 0.32. That's going to be the miss. And then it's going to be 0.68 also to the 1. We don't have to write to the 1 anymore because it's going to end with that 1 success, right? So the next one's going to be 2 misses. And then 0.68 to the 1. I'm not going to write to the 1 anymore. And then it's going to be 0.32. What are we at now? 3 misses. then 0.68. I'm getting it on the fourth try, and then 4 misses, and then getting it on the fifth try.
Wait, sir, why don't we include the fifth shot? Because it says one of his first 5.
Yeah, so he's got to make. So the scenario is he's going to keep on shooting until, and he's going to end when he gets a success. So the last one is always going to be a success. There's not going to be 5 failures, and because he's got in his first one of the, he's got to score by the 5th shot. So the last one has to be a success. Has to.
But he can't miss all 5.
He can't miss all 5. No, because he's got to score. He's got to make a basket within the first 5. So there's got to be at least one. If it was all 5 failures, then that wouldn't be part of this. He's got to score at least on one of the first 5 shots.
Okay.
Again, what the question doesn't say is that he just he stops after his first success. So he either gets it on his first attempt, his second attempt, his third attempt, his fourth attempt, or his 5th attempt. All right. So if you add all that up, you can factor out the 0.68 if you want. Like mathematically, if you were going to do this on a test, you could say it's 0.68 because they all have a 0.68 in it, and then you can just say it's 0.32, which is that one. Oh no, that's this one. That's nothing. So you can factor out. You know what? I'm just going to ignore what I just said. The answer is we don't have enough room to make it simplified. It's 0.9966. So there is a 99.66% chance that he will score. On one within the first 5 shots. Okay. Or let's do it indirect. The probability of x being between 0 and 4 equals, what's another way of doing it? So he's shooting 5 baskets. He has 5 attempts and he misses all of them. He doesn't get a success, right? So it's going to be 1 take away all 5 misses. Does that make sense? What's the probability of missing all 5? What's the probability of missing all 5? Probably missing 1 basket is 0.32. So the probability of missing all 5?
0.32 to the power of 5.
But sir, you said he can't miss all 5 shots.
I know. That's why it wasn't included here. We're not including it here. We're taking 1, subtract missing all 5 shots.
Oh, it's like the null sense. You always subtract 1. Do you remember, sir?
Yeah.
No.
So if you do 1 take away 0.32 to the 5th, you get the same answer. Isn't that amazing?
It's crazy. That's so much easier. We should
That's
just
much
go back
easier.
for it.
So anyway, sometimes you can do it indirectly. All right, I'm going to cut off the video. Call it a day. Oh, there is homework. The homework is right there, so I'll give that a 10. I think I did.
So many questions.
If you have, what's that? Oh, you have any questions with this? Like, anybody have any questions?
No, looks all good, sir.
Okay, I'm going to stop recording.